So in question 4, we have particles A and B, each with a positive charge plus Q at the vertices of an equilateral triangle with a side length D. And we're told P is equidistant from each vertex. And we are told that students Y and Z discuss the electric field and electric potential at P if we add a third particle at the bottom right vertex. And they make these following statements. And in part A, we need to evaluate the accuracy of each student's statements with respect to anything that is being inaccurate and how we can correct them. So for student Y says if a particle of a positive charge 2 plus 2q is placed at the bottom right vertex, the magnitude of the electric field will be 0 at point P. So what is correct in this assumption is that an electric field is a vector. So an electric field is indeed a vector. However, the only issue is that the charge should not have been a plus 2q charge, however a positive q charge. So instead of 2q, we need a plus q, and the reason for that is because, again, the electric field will have to cancel out, and if we have three vectors pointing like this, then they will cancel out. However, if we have a plus 2q charge, then this vector here will be larger, and therefore they will not cancel each other out completely, and therefore we will not have an electric field of 0. And then Z says to make the value of the electric potential 0 at point P, a particle with negative charge minus Q should be placed at the bottom right vertex. Now here, they correctly identified that electric potential is a scalar. However, the only issue here is that, well, since it is a scalar, we only need to consider its magnitude. And the electric potential due to the 2q charge will be some value. However, and to cancel this out, we will need the exact opposite. So we will need a charge of minus 2q in the bottom right vertex. Since the distance is the same, we only need to consider the magnitudes and the sign. So at point P, due to these two charges, we will have two electric potentials that are due to plus q. They add up to 2q, something that is corresponding to 2q. So to cancel it out, we would need something. We need a charge with minus 2q of charge, so that when we add the potential up, again, not vector-like, just simply numbers, then they would cancel out.